So here on 11b, I'm talking about benzoate ion. So I've sketched here a representation of the benzoate ion. I didn't show all the carbons. This is the only important part right here, this negative charge. I've sketched a water molecule next door. This molecule here is this ion here, benzoate ion, is a base. And it suggests water can act as an acid. Arrow going to the right will be tiny. Benzoate is a weak base. A weak base. Water is a weak acid, very weak acid. So tiny arrow going to the right. I'm getting ahead of myself here, but big arrow coming back. Structures on the right will be the benzoate has now gained a proton. So it has become benzoic acid. The water has lost a proton. It has become OH minus. You should see this is a strong base here. And that's why this arrow is big going back to the left, because the strong base, is going to actively pursue the hydrogen ion and regain it to form the much more stable water molecule. So that's the equilibrium. Lies far, far to the left. Very little on the right side of the equation. Maybe less than 1%. So here now in 11C, we're talking about sodium benzoate is an effective preservative in a jar of salsa or in a jar of soda, a bottle of soda. And that's because the equilibrium will shift based on the molecules in that type of food. So here I've represented HX. So the tomatoes have weak acids in them. That's why they taste tart, sour, tangy. Lemon juice has citric acid as well as other acids in it. This is what makes it sour. So these are acids that are in the food, represented as HX. Doesn't matter what they are. Since these are much more willing donors than the water that we had above, these Kas might be on the order of 10 to the minus 5. That's typical citric acid. Weak acids are kind of like that. Whereas water's Ka, if you recall, is 10 to the minus 16. So water is a very, very weak acid. These are much more willing donors in the tomato juice and in the lemon juice. What does that mean? It means that the arrow that used to be pathetically small going to the right is now quite decent. HX is a willing donor. Benzoate is a willing acceptor. We've got a decent reaction going to the right. So the products are very similar. Products will be benzoic acid and X minus. If you're understanding this correctly, X minus is not a strong base. It's a weak base. Only hydroxide ion is a strong base. And therefore, the arrow coming back to the left is not a huge arrow. It's just an arrow. So in a situation like this, we have perhaps the majority of the molecules will be in this state, which is important because this benzoic acid is what kills the microorganisms, kills mold. The benzoate is useless, but the benzoic acid keeps your salsa mold free. And the reason it works in this environment is because the weak acids will lower the pH, providing H plus ions to the benzoate bases, creating the benzoic acid, shifting the equilibrium to the right. This is how it works.